you'll see most of what you need for this problem in a trigonometry graphing unit in your math class. You may not have gotten to it yet. So what I'm going to go over here is just the quick and dirty stuff that you need to hack your way through the problem. Every cosine function, or sine function for that matter, can be written in a form something like this. Okay, I've got an A, which is called the amplitude, and I've got something in here which it's kind of got a bad name. It's got a name that's called the horizontal scaling factor, which is a real mouthful. I wish it had something easier. But that's the horizontal scaling factor in there. And A, the amplitude, determines how high up and down this graph goes, right? It's in that direction. Whereas the horizontal scaling factor, as its name implies, is talking about how the graph stretches and shrinks left and right, how it gets squished like a spring or stretched out wide. So there's something else called a phase shift that we are not required to know in this problem, right? The place a phase shift would fit in would be like plus a number in here. And you notice none of these equations seem to have a phase shift, which is all fine and good. We can ignore it. So there is zero phase shift. Let's just talk about how to determine what the amplitude is from the picture. Well, how high does the sine or cosine function go? In its natural state, a cosine function will only go as high as 1 and as low as -1. How high does this one go? It goes up to 2. So that means it has an amplitude of 2. We can rule out then several of these equations, right? Those guys have an amplitude of 3. We're looking for something with an amplitude of 2. If you make a 1 in 3 guess at this point, that was very easy, and you've improved your odds. So now we need to talk about this horizontal scaling factor if you're going to get the rest of the way through this problem. And to figure that out, you really do need to know what a basic cosine function looks like. Here it is. It starts at the top, comes down, hits the bottom, and that happens at pi. And then it goes back up to the top, and it hits the top by 2 pi. This distance right here between 0 and 2 pi is how long it takes the function to repeat itself. It has returned to its original starting point, and that covers a distance of 2 pi in the x direction. Okay, that's called the period. Now that's the untransformed cosine function that I just drew. Obviously, we're dealing with something that's a bit different. How long did it take our function to complete one period? Well, first of all, it's got an amplitude of 2, so it's up higher. And then it didn't get back up to its starting point until way over here at 6 pi. So the period of this function right here in green is longer. This is a period of 6 pi. So let's write that down. Period of this function equals 6 pi. Now, the way we calculate what b is the following formula. Period is defined in the following way. Period is called 2 pi divided by b. Okay, so that means this 6 pi right here, 6 pi is equal to literally 2 pi divided by b. Now, can we solve this equation? I think we can. Let's multiply each side by something. Okay, I'm going to multiply each side by b. And what that does is it gets rid of this fraction right here. Those cross out. So now look at what I've got. This is 6 pi times b equals 2 pi. Well, let's do some more equation balancing. I'm going to divide each side by 6 pi. Purpose of that is to get b by itself. So now I have the following. B equals 2 over 6, or in other words, 1 over 3. Does one of these equations have a 1 over 3 in it? Yeah, it sure does. Right here, this guy. So that's how you calculate b exactly. There's also a rule of thumb that you could have used to figure this out, which is that the period gets bigger as b gets smaller. Okay, let me write that one down. That's worth remembering. As b goes down, period goes up. They're reciprocals. Meaning, if you saw this period, which initially was only 2 pi, and you saw it get stretched out to 6 pi, that's a factor of 3 longer, which means b has to be decreasing things by a factor of 3. That's this 1/3 right there.